Hi, I'm Ashwini Lalit and we'll be discussing data-driven VSM for quality excellence. Next 15 minutes, we'll look at the purpose, need for data across people, process, and tools. Moving on to understanding the concept of VSM. Then we deep dive in the software engineering value stream. And finally, look into measures and mechanisms to build proactive quality. So let's get started. People, Process, and Tools is a well known framework that helps us assess and optimize organizations' efficiency. People are primary drivers of success. They need access to localized raw data. At the same time, they need reference to bigger picture for aligning with the business objectives. Process helps us give structure to the work. They also help us understand inter-team dependencies. Tools provide a mechanism for automation and productivity. We need data so that we can assess training needs, improve productivity and collaboration, understand effectiveness and utilization of tools, and look into pockets of inefficiencies in our workflows and reduce rework rates. VSM gives us end-to-end visibility to bridge the gap, along with agile that gives us much needed speed and flexibility, and DevOps brings in the continuous paradigm. All these methodologies together help us analyze metrics, identify patterns, and develop a continuous improvement program so that quality can be optimized and the efficiency can be improved across the value chain. So let's look at what is VSM. For those of you who are new to VSM, it's a very simple diagramming technique that helps us visualize end-to-end flow. It uses certain symbols that help us look into the process steps and eliminate waste to develop a continuous improvement. So let's take an example of refilling prescription for a waiting patient. We'll use certain symbols like a process step indicated by a rectangle, patient indicated by a smiley, and a prescription indicated by a pill. When the patient comes to a store with a prescription, the order technician first does a data entry in the computer, handing over prescription to the fill technician. The fill technician then puts the pills, checks with the help of automated pill counter. If there's a mismatch, then there's rework in the system. If everything goes through well, pharmacist finally does quality checks and then staff completes the bags and staples the prescription. Workflow gets completed here. If patient has questions, then those are dealt with, and finally the patient departs. So there are two workflows over here. One is the prescription and the other one is interaction with the patient. If you look at from the prescription perspective, each of these high part in the graph indicates the cycle time for each step. These are value additions that happen during each step. We also see that there are certain inter-process or inter-step delays which attribute to wastages in the system. Almost 75% of value addition and 25% waste during prescription workflow. If we think of it from the customer's perspective, that is patient in this case, after initial interaction, there's good deal of waiting time for the patient. And this actually is the wastage in the system. We want to improve the efficiency of the system by reducing the patient wait time. So we want to look for various areas of improvement across. Let's say by developing a parallel workflow, trying to bring the patient interaction at an earlier time, or redundancy of certain steps can be removed. What we want to look at is value is visualized always from the customer's perspective. Any activity for which the customer is ready to pay for is value added activity. You want to emphasize on that. Anything for which the customer doesn't pay for is waste, and also it reduces the efficiency of organization. Something like defects is something you want to eliminate. Then there are certain necessary wastes created in the system which actually enhance the end deliverable, but the customer may not be ready to pay for it. Something like testing is a necessary wastages in the system because customer may not pay for testing times. You want to minimize it by doing automation or left shift. We are well versed with defects as one of the important wastages in the system, but from the lean thinking perspective, there are 7 different types of wastes identified. Handoff waste or movement related waste also attribute to inefficiencies like task switching and teams working in silos. Then there are stagnation related waste like waiting times and inventory building of undelivered code or undelivered features. Then there are wastages created because of overproduction and overprocessing, wherein examples of which can be features nobody use or unnecessarily complex algorithm. These kind of wastages need to be looked at when you study the value stream and eliminate these inefficiencies. Let's now deep dive further into software engineering value stream. The software engineering value stream from a 35,000 foot can be articulated in these 4 steps. There's good deal of groundwork happening in ideation and design and planning, which then culminates so that development takes off. You want to ensure that when the development team goes further, the software or working version of the software is created as soon as possible without delays and handoff of information to and fro between the other teams. It doesn't necessarily mean that it's a waterfall model, but lean thinking emphasizes discovery groundwork done in a manner that these delays can be avoided during the actual development phase. In the interest of time, let's deep dive into development phase. What we'll do is we'll look into some of the inefficiencies that we solved in our own value stream. There were certain issues that actually created wastages, and we optimized our value stream by bringing in some of the changes that helped us get rid of these problems. Cards were completed, but the code quality measure was not known. There were too many UI UX issues discovered towards the end of the cycle. Demo feedbacks were often missed out. So, what we started with is integrating the development tools in our value stream. We integrated these development tools with the help of webhooks and REST APIs. Git commit records, Jenkins pipeline, passing status, all these measures were seen against the card. It can be very easily done, and the most important part is that as the card moves on the visual board during different ceremonies like stand up and the interaction that we have on the visual board along with the team members, you can actually look at factual information on the ground against the card. This greatly builds a proactive mechanism for the team to get the card status validated there and then. Then we moved further, modifying the value stream. We found that UI UX issues were discovered late in the cycle. Wireframes were not ready when coding actually picked up. We found that wireframe work or the design work was getting started when coding was actually getting started. So we moved the wireframing part in the story grooming value chain by adding these additional columns. In addition to design, we also added NFRs so that NFR requirements are also correctly articulated when the stories are groomed in n-1 sprints. In the story executions value stream, we added test case definition column prior to coding that helps us to practice BDD TDD prior to jumpstart coding. Then we added UI UX review prior to demo so that design lead can make suggestions, bring in small little changes there and then along with the dev person working on the cards. Another column for reviewing any demo feedbacks added after the demo value stream. These small little changes greatly improved our workflow by getting rid of these small little inefficiencies. We also started working on card hierarchy rollups so that child card progress is looked at the epic level. And if at all you want to make room for an expedite item by looking at the card ranking, and if the card has not yet started, it can very easily be deprioritized. This also greatly helped us in improving the response time of the dev team for expedited items. Let's look at proactive mechanisms now, which can be built across the entire value chain. Ideation is primarily meant for generating ideas. The strategic team wants to come to consensus quickly and ensure that ideas are handed over further for much more detailing. What you want to capture against the idea cards is NPS score, market research stats, survey stats, and these can be very easily integrated with tools with the help of various integrations. All you want to do is a what if based analysis against various business attributes so that from an organization standpoint you quickly conclude on the ideas. Meeting summarizers, discussion summaries can be put against the idea cards, which actually creates a small data lake which can be then leveraged by various recommendation engines for any future reference. In the design and planning value stream, you want to track technical stories, theme epic user story hierarchies, so that all the acceptance criteria, example map, wireframes, the card readiness, everything is articulated in this value stream against the card. At the same time, you also want to take a look at task assignment, dependency metrics, and card status change notifications. These are today inbuilt in the ALM tools. It can be leveraged very easily. Tools like Figma also send a notification when the design files are updated or ready for review, ensuring that there's a timely feedback given by card members. These integrations actually develop a very good proactive mechanism in the design and planning stage. We already looked at the development value stream. You want to track user stories, technical stories, code quality and test quality measures, your pipeline success rates against the card. You want to monitor on the board flow efficiency metric and throughput metrics to ensure that cards are flowing through the system. They are not blocked. Work on blocking reasons. At the same time, you want to ensure that the development tools are integrated into the ALM tool, and along with business rules, you can actually notify if the card measures don't fall into place with these development tool integrations. In the production value stream, you want to ensure availability of your software. You want to ensure initiatives of strategic importance where the user feedback is captured and the A/B testing is done, or your feedback mechanisms are monitored. The response times are monitored. So various metrics like monitoring tools like New Relic alerts to DevOps teams whenever anomalies are detected, or there are alerts triggered when the performance metrics exceed beyond predefined thresholds, or deployment status notifications, or success or failure notifications, which are sent to Slack and emails, can also create cards in the value stream ALM tools. You want to monitor cycle time, whether the crisis management is in place and the response times are monitored so that you know that the escalations are dealt with at most importance. These kind of proactive mechanisms actually ensure that the team is responding to the much needed attention area more efficiently. With that, we come to end of this session. What you want to monitor across the entire value chain is what are your value added cards and non value added cards? What are the metrics that you want to track against it? Various development tools which integrate into the value stream, and then the ALM tools and the value stream itself integrated with development tools can provide a proactive mechanism so that these metrics and measures can be tracked in real time. With that, we come to end of this session. What we have learned today is VSM can reveal process inefficiencies, and you can leverage that information easily with the help of agile and DevOps by building proactive mechanisms and data capture. As testers, we want to move beyond boundaries of user stories and defect cards and enable a systematic approach so that quality can be built across the value stream. Thanks so much for listening to me patiently. Thank you.